This integral can be doctored up so we recognize it as an inverse trig function, but we could also do it with trig substitution, and so that's what I'm going to do here instead of doctoring it up. So this, I need to label sides here, so I get this, it'll actually be the square root of this as one of the sides. So I'm going to have this side be 2x and this side be 1, and this side would be the square root of 1 plus 4x squared. So I'm going to use tangent theta, and that's going to be opposite over adjacent. And so I could solve this for x and have 1/2 tangent theta equals x. Well, let's go ahead and find the dx. So that's going to be 1/2 secant squared theta d theta. When I do the substitution here, I need to either replace these limits of integration in terms of theta or do it generally and then resubstitute. So let's go ahead and replace those. If I put a 0 in, and I could do it here or here, I'm actually going to put it up here. When is the tangent 0? And that's going to be at 0. And then putting in a 1/2, that'll leave me a 1. When is the tangent 1? And that's at pi over 4. So I've replaced my limits of integration. And now I'm going to do the substitution. So this is going to be 1 plus, now I need 4x squared, and this is actually 2x, so if I squared both sides, that would just make that tangent squared theta. And so now I also need to replace my dx, and that's going to be replaced with 1/2 secant squared theta d theta. Let's see what we can do to do some simplifying. So we could bring this constant out in front. So we're going to do that. That's going to be 5/2 out in front. And this could be replaced with secant squared theta. And then that will cancel with this one. So I'm just left to integrate from 0 to pi over 4. I've just got d theta. So that's going to be 5/2 theta evaluated from 0 to pi over 4. So that's going to be 5/2 multiplied by pi over 4, and the lower limit is just going to be 0. So we have our answer. That's just going to be 5 pi over 8.